Hello, my name is Rohit Talreja, and in this session, we'll be covering Google Cloud's security, privacy, and compliance solutions for healthcare. I am a product manager on the healthcare and life sciences team within Google Cloud, and my primary focus areas are artificial intelligence, security, and governance. So before we get into any specific technologies and solutions, it actually helps quite a bit to deep dive into the healthcare and life sciences market to understand the regulatory landscape and the challenges that organizations are facing. So, if we look at one overview study on the regulatory burden that hospitals and health systems face, they calculated a significant financial and time cost to compliance. So, in this report, regulatory compliance is not just the security and privacy related aspects. It also covers areas like documentation, patient safety, and others. So, if we look at just IT compliance, specifically, the information security, privacy, compliance documentation of the infrastructure, that cost is still a major component, but it's not everything that you see on this slide. Looking more closely at the figures themselves, across the industry, healthcare organizations are spending approximately $39 billion dollars a year in aggregate just on the administrative activities of compliance. This presents a huge financial burden to the organizations who need to be focused on providing care and optimizing their infrastructure as well. Uh, the financial cost isn't the only thing, however. There are also approximately 59 full time employee equivalents dedicated to regulatory compliance within an average size hospital. This includes approximately 15, or about a quarter of which, are clinical staff, such as doctors and nurses. Looking at the patient impact of both the financial aspects and the clinician aspects, the cost of compliance results in material time taken away from patient care and even potentially creates redundant efforts within an organization. So when we look through, the cloud provider technology, one of the things that we think about is how can cloud technologies and cloud services help reduce this burden of compliance? Now, where does this compliance requirements come from? Unfortunately, there isn't one single answer that we can tackle that addresses all compliance requirements, all security and privacy requirements for an organization. Instead, we have to look at kind of the amalgamation of different sorts of regulatory frameworks, industry standards, and other pressures healthcare organizations face for compliance. So the first thing to look into is data privacy regulation. This is highly specific to a particular region, such as the U.S., the EU, or even specific states or counties or provinces. However, in general, data privacy regulation is a legal requirement relating to data collection, processing, and sharing. The penalties for breaking these data privacy regulations also range. They can vary from financial penalties to lawsuits to criminal cases, depending on the specific violation, how severe it was, and what regulation is in question. And finally, because these regulations are meant to stand through the test of time, they're generally not descriptive. You won't see specific regulations say specific key lengths for encryption or exact technologies to use, but instead they're generally more descriptive. They'll say things like data must be protected in the following ways, and often there's no official certification for these regulations. Instead, organizations have to ensure that they're aligning to the letter and spirit of the regulation, but there is room for some organization-specific interpretation. So, if we look at just one or two examples of data privacy regulation, in the U.S., the one that most healthcare organizations are familiar with is HIPAA. And HIPAA is a regulation, again, for the US that covers the use, disclosure, and security of protected health information. And protected health information is a specific defined category in HIPAA, but essentially it's patient information, information relating to the care of the patient, any bills they receive, et cetera. For HIPAA specifically, it applies to two types of organizations in the US: covered entities and business associates. And these categories just define how healthcare organizations operate. Covered entities are generally the point of care, the insurance companies, the healthcare data clearinghouses, and then the business associates are any vendors or partners of the covered entity that may do data processing, storage, or transmission on behalf of the covered entity. Again, as mentioned, there's no official certification for HIPAA, and the requirements are not very prescriptive. However, they do give a general overview of how data should be used, collected, protected, stored, and so on. Uh, there's another example of this, one in the EU that covers the entire EU jurisdiction and covers some foreign jurisdiction where EU citizen data may be processed or transmitted. So in GDPR, again, you'll see there's a parallel to HIPAA in that it covers the scope, processing, and transfer of personal data. In this case, personal data includes some aspects of healthcare data as well. The GDPR does not use the same language as HIPAA, but it says GDPR is applicable to data controllers and data processors. There isn't an exact parallel to covered entities and business associates under HIPAA, but you can tell that they're trying to segment the categories of people who have collected and have ownership of the data versus people who have temporary access for a specific case. And finally, again, there's no certification for GDPR, and organizations have to kind of align with its guidance. Going into the next topic is government frameworks. You can think of these as requirements for contracting with government agencies. The penalties here are not usually as severe as for the data privacy regulation. However, they can still be very material. Breach of government frameworks can jeopardize contracts with government agencies, or it can result in lawsuits to recoup any damages. Here, the certification requirements are generally a bit more prescriptive. We'll go into a couple examples later. But unlike the data privacy regulation, which contained general guidance, government frameworks tend to be very specific. They can have hundreds or thousands of specific controls that an organization has to implement, test, and document. And there are different degrees of compliance depending on the framework. So one common example here, again, for a US centric view of things is called FedRAMP. And FedRAMP is a US government requirement for cloud service providers specifically in order to allow the government agency to purchase cloud provider solutions. And FedRAMP tends to be very prescriptive, and there are multiple levels of compliance. So organizations can meet a number of different bars of FedRAMP compliance, which allows them to operate certain workloads or sell certain levels of technology to the US government agencies. There are, a lot of government frameworks depending on where in the world you are, which government agencies you're working with. Another example that comes up is the UK National Health Service toolkits, and these are guidelines for technology outsourcing. They're a little bit less prescriptive than FedRAMP, but still more prescriptive than data privacy regulation. There's no official certification here, so you'll see that government frameworks tend to be a little bit more varied on whether they have an official certification path or not. Another category of requirements comes from industry standards. And industry standards tend to be committee driven for a specific market or use case. Most require an independent third party audit. It's not something that you can generally self attest to within an organization. There has to be some sort of checks and balances in place. And most importantly, participation in industry standards is voluntary in general, but it's often enforced on a contractual basis between a vendor and their customer. So there's no specific penalties like there are for data privacy regulation that you'd get from the government specifically, but you may be susceptible to specific agreements with your vendors or your customers, depending on what industry standards are in scope for that relationship. There are a few examples here. Most people are generally familiar with the SOC family of standards, and these are globally recognized standards for IT operations, security, availability, confidentiality, integrity, and so on. This is, a very general purpose standard that's useful for a lot of technology providers across different domains. And then we can look at two specific industry standard examples, one for healthcare and one for financial services. Obviously, these aren't mutually exclusive. There are financial services organizations that operate in the healthcare space. So, it's important to understand that the domain of the industry standard does not necessarily map one to one with the organizations that have to comply with it as part of their business obligations. And the last thing to touch upon in this session is good practice regulations. And good practice, or GxP regulations, are actually a combination of government regulation, industry standard, tribal knowledge, and other organization specific controls. They tend to be more nebulous for specific use cases. However, some examples that are relevant to the healthcare and life sciences industry are good clinical practice, good laboratory practice, and good manufacturing practice. There are some common considerations for these various GxPs. Often they have similarities in the configuration validation that organizations have to do, the contingency planning process that organizations have to have in place if a disaster were to occur, as well as access control and audit trails to make sure that any access to the system is properly documented, any changes are properly validated and documented as well. So this is essentially the summary of all of the various regulatory and industry standard frameworks that make up the IT side of healthcare compliance. And if you take a closer look and distill all of these various regulations and other requirements relevant to the industry, you'll see that there are quite a lot of commonalities. And this slide is meant to indicate some of these commonalities that healthcare organizations are facing when it comes to setting up an infrastructure and IT program. So, at the infrastructure level, the physical machines, the virtual machines, the software running on the virtual machines, it's important that all of these various pieces are appropriately hardened to protect against vulnerabilities that may be appropriate for that level of the stack. So if we think about network security, one of the common attacks that can take place is a denial of service attack. And protecting this at the network level is appropriate because it is fundamentally a network and scaling type of attack. At the data protection layer, one of the common protections is encryption. And encryption is applicable at this layer because you want to make sure that the data that resides on disk, the data that's being transmitted between various services, and even your backup systems has the proper levels of encryption to protect against vulnerabilities at the data storage level. And then if you keep moving up the stack, a lot of the industry standards and regulatory frameworks also have recommendations around identity and access management, endpoint security, how you allow external users to connect to your systems, how you record accesses by external users and make sure there's a permanent audit trail, so on and so forth. So at this point, it's important to kind of transition to see, okay, how do we move from the general scope of requirements into something that is specific to Google Cloud and specifically implementing secure, private, and compliant workloads on Google Cloud. The first thing that's important to discuss when talking about cloud is the shared responsibility model, and specifically the shared responsibility model in detail. The shared responsibility model says that in contrast to traditional IT systems, where the IT owner is responsible for maintaining the infrastructure stack top to bottom, with cloud services, that responsibility is shared between the cloud provider and the in house IT team of the organization. And it's beneficial from multiple angles. The shared responsibility model allows each organization to focus on their specific projects and core competencies, while Google, the cloud provider, focuses on managing the services and the underlying infrastructure. And this can be from a security standpoint, from a scaling standpoint, from a freshness of the IT stack, so to speak, making sure that the machines are up to date and replaced periodically. And there are other benefits from this model as well. It allows organizations to benefit from Google's world-class security and privacy teams who are in charge of maintaining the infrastructure. And you can also take advantage of the cost savings that stem from Google's ability to purchase these technologies in bulk and efficiently manage the data center environments and delivering the cloud services. So on this diagram, you can see that different levels of services have different levels of responsibility related to security, privacy, and compliance. And this is generally a function of how much control the cloud service user has over the environment. So, in an infrastructure as a service or IaaS service, you'll see that there is a fair amount of responsibility that the customer's IT team still has to manage. But this is also reflected in the level of control that their IT team has over the system. So if there are requirements to have a specific guest OS image, a specific network topography, a specific level of encryption using specific key length, specific encryption algorithms, that level of control comes with the comparable level of responsibility to do things appropriately. And therefore, you'll see that the cloud provider, Google, cannot manage as much of the system as they can in other services. So when we move kind of up the stack into more managed services, let's say a platform as a service offering, you can see that the level of responsibility managed by the cloud provider increases. And this is to reflect that the cloud provider is now taking more of the decisions and responsibility around scaling, security, compliance, and providing a managed service to the user. And finally, at the right hand side, with a software as a service application, the cloud provider has taken on a majority of the responsibility in maintaining the service. And then the user only generally has to worry about what data they put in the application, who they share access with, and so on and so forth. So there's a column missing in this diagram, and that's kind of the traditional IT model before cloud services. And that would be where an organization's in-house IT team or outsourced IT team was responsible for all of these activities related to cloud, to the security of the platform. And that would be a fully blue column, so to speak. So you can see that even in the most flexible cloud services, there's still a decent amount of responsibility that the cloud provider is managing. So let's take a look at some specific examples related to Google Cloud. If we look at a hypothetical shared responsibility matrix for Compute Engine, which is our infrastructure as a service compute platform, you'll see that at the bottom of the stack, Google takes full responsibility for the hardware underlying the service, and we implement that using our proprietary hardware stack. We also take responsibility for the boot process, the kernel, the storage and encryption at the physical layer, as well as the networking, again, on the physical side. And this is done through Google's proprietary technology and hardware stack to make sure that the vulnerabilities are mitigated, attacks can be prevented and or mitigated, and that Google has taken responsibility for the security and compliance of these components. Turning focus to the customer responsibilities, they start pretty much at the anything that is installed on the virtual machine. So the guest OS, the choice of OS is with the user. What data they put on the machine is up to the user. How they configure the network, how they authenticate users to the system, basically how they scale the virtual machines up and down depending on traffic going to the application, and then all the way up to the top of the stack, what web services run on the virtual machine. So there's a lot of freedom afforded to the users of Compute Engine to configure and manage their applications appropriately, but that also comes with the responsibility to do it correctly. Transitioning to a platform service such as BigQuery, you can automatically see that Google's responsibility has moved up the stack, so to speak. Google is now responsible specifically for maintaining the operations of the service. And what that means is BigQuery scales automatically for the amount of data that customers put in the platform. So Google is handling, adding more memory to the system, adding more storage, adding more compute capacity, and customers do not have to. But there is still customer responsibility here. And the responsibility, again, goes from which users have access to these BigQuery instances and BigQuery datasets, all the way up to what applications are able to manipulate data in BigQuery. Going to the far end of the spectrum, an example of a SaaS platform in Google Cloud is Google Drive. And a hypothetical shared responsibility matrix for this shows that Google's responsibility moves quite far up the stack. Google is now responsible for deploying the service in a way that customers can appropriately access it. But customers, again, will always retain some level of responsibility for choosing what content they put into the service, who's able to access it within the customer's organization, and so on. So if we summarize Google's technology suite for helping customers with their shared responsibilities, you'll see that Google has products and services to help with shared responsibilities in all of these areas. So on the infrastructure side, there are things like shielded VMs, which can help protect the infrastructure as a service offerings. There are services like data loss prevention and VPC service controls that can help these platform as a service services manage their data appropriately and access controls appropriately. And then finally, at the top of the stack, even with regards to SaaS services, there are endpoint security and identity and access management solutions to make sure that access is appropriately controlled to a SaaS application, even though the customer is not responsible for managing anything below a certain level in that stack. And finally, in regards to the overview of Google Cloud, I mentioned earlier that there were a number of government regulations, frameworks, industry standards that were relevant to healthcare and life sciences. Here is an overview of Google Cloud's overall compliance posture. This is not an exhaustive list of everything customers can do on Google Cloud, but it is a representation of frameworks that Google Cloud adheres to, some of which have self-attestation, some of which have external third-party attestation, and some of which have specific contractual indicators as well. So at this point, I want to transition focus to setting up and managing healthcare workloads on Google Cloud, and specifically how you can best manage your shared responsibilities and adhere to the various security, privacy, and compliance requirements that you need to. And one of the offerings that we have in this space is called the Healthcare Data Protection Suite. And the Healthcare Data Protection Suite is an integrated tool for deploying, monitoring, and auditing Google Cloud environments and workloads that are running on Google Cloud. And by integrated, I mean there is very little lag between the deployment of the resources themselves when they start getting monitored and when the monitoring data is available for investigation, triage, documentation, and so on. How this works at a technical level, we have integrated infrastructure as code deployment templates, command line tools, and continuous integration, continuous deployment pipelines to enable easy, verifiable, and reproducible deployment of Google Cloud architectures, as well as common healthcare and life sciences solutions. So what this means is we have some predefined templates for common healthcare workloads on Google Cloud, such as HIPAA-aligned deployments or R&D platforms that account for various compliance guidance, as well as technical best practices for setting up Google Cloud services. And there is a automation for this deployment. There's automation for validating that everything in these infra as code templates was deployed appropriately. And then there is continuous monitoring against a set of defined policies that are defined at the time of resource creation. And having this suite fully integrated means that you can define your workload and the monitoring policies side by side. You can ensure there's no or minimal gaps in monitoring coverage and start scanning for policy violations as soon as the resources are deployed. And this is a little bit more useful than some other tool suites where the monitoring, deployment, and auditing are all separate steps. In some of those other workflows, the environment gets deployed. There can often be a lag of several hours to several weeks between when the resources are deployed and when they begin to be monitored, and then another lag between when the monitoring data is available and when it's available for triage and investigation in any sort of UI interface. So if we take a look at how this works in detail, there is a suite of configuration libraries that we've made available to our users. And what these allow users to do is create deployment modules. You can have deployment modules for specific services like BigQuery, Google Cloud Storage, and Compute Engine that tell the application how these services should be configured, where they should be set up, what the IAM policy should look like, what the monitoring rules should look like. And then these are all stored in the form of a declarative template. And once this template is ready to be deployed, we have integration with Terraform for continuous deployment, continuous integration, and automation of the deployment practices. And what this allows you to do is, do your code reviews on automation code. You don't have to wait for the environment to be set up to do the validation. It also helps you set up multiple instances of the exact same infrastructure for different purposes. So you can imagine potentially some GxP related requirements where you have to have identical production, development, and test or QA environments. And this automated template framework allows you to set these up exactly equal to each other. You don't have to rely on making sure you click the right buttons in the console or run the right command line arguments in the same order every time. Diving deeper into these templates, the deployment templates can be written in a native Terraform syntax or in our own declarative YAML syntax that compiles into Terraform. And different organizations may have different preferences for how they use these tools. Organizations that have Terraform code already can reuse that, or organizations that don't have existing Terraform code and prefer a declarative YAML syntax can start there and generate the Terraform output. As I mentioned, these deployment templates are modular. They can be linked together to make larger projects or organization structures for the workloads. And they also have accounted for resource-specific configuration. So where a specific resource has a configuration parameter, you can account for that specifically and not have to set it globally after deployment. So this example on the slide is setting up a project for holding data. And what this is doing is it's setting up a BigQuery data set with a data retention policy to map a specific privacy or compliance requirement. It sets a data viewer group as well as a project owner group that has access to all of the resources within a project. And essentially, once this template is deployed, it will result in a BigQuery data set with all the appropriate settings and controls on it. And leaning on from this, the resource deployment feeds directly into the monitoring policies. And the monitoring policies can be auto-generated based on the deployment template. So where there is a setting for IAM policy in the deployment template, the tools can infer that you might want a monitoring policy to prevent changes to that IAM configuration. Or the monitoring policies can also be explicitly specified. So if you have a very specific set of allowable contractual requirements with your customers, and any one of those settings is allowed, you can set a monitoring policy that allows you to set any one of those configurations, but not deviate from that approved set. By default, the scanners for these monitoring controls run at a default 12-hour interval. However, this can be configured to any interval that you're comfortable with in your organization. The examples of available monitoring policies are centered around compliance requirements, specifically the security and privacy compliance requirements. And some examples are access control lists and IAM policies. Ensuring that your cloud audit logging settings are appropriate, making sure that the APIs that have been enabled in your project are appropriate for what that project will be doing with data. And going further down the list, if there are specific data retention requirements or data lifecycle requirements, those can be monitored for as well. So the example on the left side is showing how to explicitly specify monitoring requirements in the configuration interface. And what this is doing here is showing that there's two controls that are being monitored for. One is the policy member domains, which you're allowed to have membership within the foo domain or the bar domain, for example, and then the allowed shared VPC host projects, which are declared beneath. And what these monitoring rules will do is, if there's any deviation from the two named policy member domains or the two VPC shared host projects, you'll get an alert in the monitoring toolset that claims that there has been a deviation. And finally, the last step in this integrated process is the auditing and reporting. So the data protection dashboard here enables users to visualize, track policy violations captured by these monitoring tools. You can dig into the policy violations, view the scan results in raw detail, as well as understand long-term and short-term policy violation trends. And having this suite fully integrated helps maintain the context all the way from deployment to the end of the process, which is auditing, all the way back to starting over with redeployment or iterations on top. So this, an example of a GCP environment deployed with the data protection suite is this HIPAA-aligned deployment. You can see that there's a connection to an on-prem interface that helps bring data to and from Google Cloud. There's a networking project that manages the interconnects, the routing, the firewall rules between the on-prem and the cloud environment. And then there's two cloud projects. One is for hosting the data and application itself, and one is for the security operations that run the monitoring tools, as well as the auditing UI. So this can be deployed in just a couple hundred lines of configuration and set up within an organization in a few minutes. And this is in contrast to the several days or weeks it would take to get the same environment set up and validated through more manual means. So wrapping up on the data protection suite, the main benefits here are accelerated migration timeline, decreased time to realizing the value of cloud, and pre-applying the best practices for security and compliance. If we look at one other area of Google Cloud that helps organizations meet their privacy compliance requirements specifically, it's de-identification. De-identification is the removal of personally identifying information from data such that you can no longer identify the individuals that the data or data set links to, but that the data retains utility for research and commercial development purposes. And both aspects are important, right? Because it's important to maintain patient privacy, but also not delete the research value of the data set in the process. De-identification is important because it can prepare data for applications that are outside of the traditional clinical domain. And some examples of this are ensuring that data is private for analytics, for sharing securely with other organizations, and for using in application development. De-identification is an important aspect of several privacy regulations, and one of those is HIPAA. So revisiting HIPAA, it allows for using de-identified data in secondary use cases. Obviously, there are certain limitations here, but for the most part, once data is de-identified and provably de-identified, it is available for use outside of the clinical workflow. And HIPAA defines a couple different approaches to claiming that data sets are de-identified. One is expert determination, and the other is safe harbor. It's important to note that while these different approaches have different benefits, depending on whether the data set is structured, semi-structured, or unstructured, neither method is definitively guaranteed to eliminate a re-identification risk. So looking at the identifiers that HIPAA is most interested in, specifically for the safe harbor approach, you'll see that there's kind of 18 categories that are important to consider. Most of them are fairly straightforward and easy to interpret why they may be personally identifying, such as names, telephone numbers, fax numbers, email addresses, websites, faces, and so on. There are also some identifiers that on the surface may not be immediately identifying, such as zip codes or cities, as well as some other aspects. But you can imagine that if a zip code is small enough or there are few enough people within a particular zip code, that statistically it could be used to indicate a subset of population that the data may belong to. So that's why HIPAA tends to have opinions on geographic location de-identification. This slide kind of shows the value of maintaining research value of a data set during de-identification. If we look at the example on the left, we can see that somebody's social security number is in this message, as well as their phone number and their name. And then on the right side, there are three different levels of de-identification. The first level is just included for completeness. It's essentially deleting all of the data. We have fully de-identified this message, but we have also eliminated its research value. The second example shows how to remove all of the PII, but also at the same time remove all of the utility of this example. The bottom example retains some of the PII, specifically the name and the phone number, but it removes the especially sensitive PII of the social security number. And in this case, this example is the most useful for completing the task that needs to be done here. And in this case, helping the patient get an appointment scheduled, but also ensuring that their sensitive PII is not overexposed with the social security number. So there are tools on Google Cloud to help with de-identification. The Healthcare API is our data platform for healthcare data in standardized formats such as FHIR and DICOM. This service has an integrated de-identification tool that can be used for de-identifying data sets, then joining and exporting them to things like machine learning models or analytics and BI tools. And this is, when you want to analyze an entire data set in batch. There is also the ability to process individual records through the de-identification workflow. And this can be useful for real-time applications like viewers or patient data applications where patients and providers are interacting in real time with each other. This is a quick example of how the de-identification tools work. The FHIR format is a mixture of structured and unstructured data in a key value format. So you can see that there's some structured PII on the left side in this original FHIR record, and then there's also some unstructured PII at the very bottom. Through the de-identification tools, the FHIR record has been processed, the structured fields have been removed or transformed, as have the unstructured fields. For organizations that want a specific method of de-identification done, but also don't necessarily have the technical abilities in-house to do so, we have a program that pairs partner services with customers to perform some of these de-identification activities. And this can help customers get access to de-identified and validated data without necessarily needing to hire specific technical or privacy skills in-house. And with that, it's a good segue to say that there are partners available for all aspects of the security and privacy compliance workflows, not just de-identification. This slide shows a quick picture overview of some of our partners in this space, many of whom you may already have relationships with. So it's important to note that there is a large partner ecosystem on Google Cloud for the healthcare industry when it comes to security and privacy compliance. And with that, thank you for joining this session. Hope you learned something useful.